Yeah, this is a talk on many moving MOCs. Let's get started. I am Adam Williams. I've been an AFOL for about 10 years. I build with my wife. She's over in the corner somewhere. Raise your hand, Smo. You're in that corner. She's over there. So yeah, we build together. We're in the San Francisco Bay Area. We grew up in the Seattle area, but we're in the San Francisco Bay Area. And we generally, for the most part, we do minifigure scale displays. And my jam is coming up with moving elements to bring those MOCs to life. And that's what this talk is about. So yeah, here's an example. We've got a juggler here, and I've got the moving elements to make the balls, come to life and help add some more fun to the MOC. So goals for this talk, I'm going to introduce many moving MOCs, some lessons learned over doing this for many years, and help inspire others to make more moving MOCs. So that's the goal. So I want to just get down to basics when I talk about Lego technique. So there's the Lego brick system. We're all aware of that, right? The Technic system is where you have additional holes, right, and axles and gears, and you can add moving, rotating elements to those MOCs. And so what I like to do is to kind of integrate, they have pieces that are use both system and Technic elements, and so you can integrate these two systems into one to add moving elements to, something that is primarily Lego system. So that's my jam. Okay, so moving elements. So I'm going to go quickly through the motors and the various moving element product lines, right? So about 20 years ago, there was a 9-volt system. So these are the kind of parts. You have a battery box or a speed controller, something to create power, and then you have those little black wires, and then those go to motors, right? And so that's what the 9-volt system looks like. Then, about 10 years ago, you had the power functions product line, and that's what those elements look like. You've got a battery box. So the new things they added there, they added a remote system, and then they have different kinds of wires and different kinds of motors. They are somewhat backwards compatible. And then the the current product line that's being out is the powered up product line. And those have a different kind of battery box, and they're generally controlled. They can be controlled using your phone, which is cool, and then they have different motors. And the nice thing about these powered up is that they are programmable also. So you can not only just turn them on or off, but you can sequence the different motors and take feedback from various sensors and do like a robotics setup. And they had robotics lines in the 9-volt and the power functions line. So they had what's called a Mindstorms product line. So they had programmable bricks where you could not just turn them on and off, but you could program them to run in sequence or run based on feedback from a sensor. So in the 9-volt area, they had that yellow Mindstorms brick. In the power functions line, there's kind of two. There was the NXT and the EV3, and then in the powered up line, it's fully compatible with the powered up system, right? So anyway, that's kind of an overview. So if you're doing a moving MOC, you're going to need to pick elements from these, and they're somewhat compatible. I'm not going to go into all those details. And there are advantages and disadvantages to these various product lines. Generally, my advice, I work in all of these. I work with what I've got, right? So that's the advice. Anyway, I'm not going to go into high level on details on that. So the high level lessons learned that I always strive for, and will be a theme in all of this, is you want to strive for simplicity. You want to be patient and expect that you're going to have to revise the moving elements many times in design and probably when you're out showing it, right? When you're exploring those concepts, the first thing that I look at, so first of all, we're building a MOC, and I'm like, how can I make this awesome? How can I add a moving element? So the first thing I think about is how am I going to translate that motor rotation to the actual motion that I want to see the minifigures or the elements in the MOC do, right? So the first thing to figure out is how do you do that? And then the second thing I think about is where am I going to hide all the mechanisms, all the electronics, all of that. And if I can figure out an answer to those, then it's worth moving forward on, right? And then the final advice I have is test more than you need to. I've never done a MOC and been like, oh, I tested it more than I need to. It's always like, oh, I should have thought about that. I should have tested it before I got out to the convention center and found out that there was this problem. So test more than you need to. And that will come up as we talk about MOCs that I've worked on. So with that, I also I got some advice early on when I was putting this together. Someone said, hey, you should like show some instructions for something that you could do. And so here's a very simple example it's kind of similar to what's out in the display. There's a boy chasing a dog up in our medieval village, and so down below you can see kind of exploded vehicles. So you've got a motor, and then what we've got is a worm gear drive, and that is a compact way to reduce the speed on the motor. So the motor, if you just put an axle on that motor, it's going to spin really fast, and you need to. One of the things you have to do oftentimes is figure out a way to slow it down, and so. An easy way to do that is to grab that worm gear and then put another gear, and then that makes the motion go up, and then you can put a little circle on it and put a minifigure on it, and now you've turned the motion into what you want to see and get that minifigure up. And so there is a QR code at the top of the slide for instructions for this thing, if you're interested in taking it and building upon it to do whatever you want. Anyway, there's the idea, right, you've got a worm gear that spins, and then that translates the motion into that that gear there, and then that makes the motion go up. Yeah. So, and then yeah, that's the idea. So, yeah. With that, questions. I tried to put some questions every few slides in case people had questions on anything going forward. There'll be another round of questions in a couple slides. Anything online? Any questions on that? Did I move on? Okay. Oh, question. Yes. Mm-hmm. Sorry, what was the last part of that? Oh, yeah. If you have a larger gear, when that worm gear, the thing with the spiral, that spins, one revolution of that gear equates to one tooth of the round gear of that. So if you put a bigger gear, it's going to have more teeth, and so that revolution will move that gear a little slower. And so you'll end up, the person running around will go slower if you put a bigger gear here. And so the idea with gears is that you have a motor that's transmitting motion. If you make that first gear bigger, it's going to make it go faster. If you make that second gear bigger, it's going to go slower. And so you make that second gear. If you make this one bigger, it's going to make the person go slower. And so that's part of the development of this, is figuring out what type of gear, what combination of gears you want to get the right speed on this. Or you figure out an electronic solution. You get motors and battery boxes that you can adjust the speed to get the right speed you want. So those are the two options: is a mechanical solution or an electrical solution. Yeah. Oh, well, so part of that depends on how much resistance the thing above it does. So like what I've shown on this is just something pretty small, just that little round plate and that minifigure. And so I would guess that there's not a lot of friction on that, and that you could get, that would probably run really fast if you wanted it to. It depends on what you're making. If you're making something that's got a lot of gears, a lot of stuff on it, you might need more torque on those. So that's something you kind of just develop as you're building the mechanism to figure out what's going to work. So yeah, I think we'll move on and we'll look at a MOC. So first, one of the first MOCs I did that was moving was, we wanted to do this city building, and I was like, let's do a roller skate rink inside. And so we have the minifigures roller skating around the rink, and let's show how that works. So inside we have the skaters are going on this black Technic chain. It's 1 stud wide, and so the motor is in the middle. It's got that worm gear again that goes to a big gear, and then that interfaces with the chain that rotates around the roller skating rink. And then every once in a while on the chain, we've got this tank tread and then a 1x1 round brick that you can put on that tank tread, and then you can put a minifigure's foot on that. And so that allows the minifigures to go around the roller skating rink, and it's super fun. If you do this nowadays, there's actually a part from the LEGO Ideas Pac-Man set that combines that you can, instead of using that tank tread and that 1x1 round brick, you can use the piece from that set. But at the time this was developed, that element didn't exist. Anyway, so that's the idea with how this worked, and it worked very well. It was small and simple, didn't have a lot of gears, a lot of complication, and we were able to show it for a holiday season at a local show, and didn't really have any problems. So that was awesome. So the next year we're like, let's make it bigger. Let's do the same thing, but let's do a large mountain, and we'll have skiers go down the slope, and then we'll have them go into like a tunnel behind the mountain, and then they'll go back up under the mountain, kind of hide that, but and then have them come out the top and ski down, right? That was the idea. So it was the same concept, but it was a lot larger. And it had more bends, and it was slanted on a hill, right? And, the first advice, is great. Start with something simple and then make it bigger. And I naively thought, I'll just make it bigger. There won't be any problems. There were lots of problems. Anyway, here's an inside of how that looked. And so the first problem that you run into as you scale up these belt issues is you have to get the tension on these belts just right. If you add too many elements of that chain, then it gets floppy, the chain kind of sags down, and it might lose alignment with those gears and like fall in the mountain, right? That's no good. And then if you put too much tension on those chain, it can break. The chains can break. And so that was the first challenge. And I didn't notice it on the roller skating rink because there was not that much chain, not that much not that much flexibility when you have not that much chain. But as you make it bigger, now you run into more problems. The other issue I had was this was a big MOC at the time. We didn't have that many parts. We were trying to optimize like how few elements of these large, Technic elements could we use to build this support structure. So it wasn't as strong or as rigid as I wanted. And what we found is like it worked fine in the build space at our house where we were building it. But then we transported it to a show, and things warped, things got floppy, and the thing needed a lot of repairs at the show. And so that was the first time when it was like, gotta test everything, including transporting the MOC to the show. So now what I really try to do is I try to bring prototypes of a MOC to a club meeting. So I'll try to bring that to there just to see, if I take this and put it in a box and take it in a car and pull it out of the box, is it going to still work or is it going to fall apart, right? And so the lessons learned are make sure that your motion structures are rigid, that they're not going to be flopping around, and that you can easily grab it and move it and have it stay in one piece. And then the second thing is test more, right? The thing I really, one of these first MOCs, I was trying to get those gaps. Those gaps between the chain and the people, I was trying to get that as close as possible, right? That's always the challenge with moving MOCs, is you've got to add some separation between the moving parts and the non-moving parts, but you want to avoid those gaps because they don't look very pretty or realistic, right? And so I spent a lot of time really fussing over those gaps and trying to get them as small as possible. And I think looking back, I'm like, everybody thinks this is cool. My experience is that audience members have people have a lot more forgiveness for gaps when you have a moving element. So it's not worth stressing as much about those gaps between those. So it's better to add a little bit more safety factor, a little bit more gap than you think you need, especially if it's your first MOC or if it's a new technique for you. The other issue that I ran into is I put this motor deep in the middle of the mountain and didn't think about how to get the motor out. And if you have, and then it's like, and then the motor breaks, and you got to go take a ton of stuff apart to get the motor. And so that's something to definitely think about, is that any motor, or the gears and the mechanisms, it's going to break. And so think about how building indoors or building in lots of space to get at these motors. And part of that means it needs to be kind of big. Your mock generally needs to be, my rule of thumb is it's got to be at least a 16 by 16 plate footprint for a mechanism. Anything smaller than that, and you run a risk of you're trapped in a corner, you can't get the mechanism in there, and even if you can't get your hands in there to get at anything. So thinking big is a good idea when you want to put a motion in there. And thinking about how you're going to be able to access that is something to think about. So, yeah. Questions on any of that? Yeah.
So that's a question for anybody who's big, but especially when it's that delicate. Mm-hmm. How far are you willing to go geographically to your stuff? And do you ever ship anything?
So we are in the San Francisco Bay Area, and we drove our mock from there to here. So drove 1,000 miles in a trailer, and we definitely, we've been doing this for a while, so I tried to build my things pretty rigid so that there weren't a lot of problems, and then also budget time getting there. We got there right at Thursday at 2, so that we had until Friday night to get things working. So to do both, right? Try to build it strong, and then budget time, because things are probably going to break in transit. And especially with moving mocks, if things, it may look fine, but something may have just shifted a little bit, and now you've got a clearance problem, and so something to be careful about. So, yeah. Does that answer your question? Yeah.
Do you ever ship anything, not transport anything?
Oh, I haven't personally. I don't have a lot of experience with, with air transport or anything. Our mocks have generally been so big that it's been really expensive to try to get somebody to ship it. And I worry about, having somebody else grab it and ship it. I'm not sure how much better that is than just you doing it and being careful about, your stuff. So, yeah.
What have you found regarding the life of the motors and how long they
That is a good question. And I think it depends on the product line that you're using. So, let's see. So the mock the big mock that we have down there, that Castle, that's got about 15 motors. I'd say about half of them are 9-volt and half of them are power functions motors. We don't have any powered up in that mock. And of those, 7 or 8 motors, we've shown it. Oh, that's a hard question. I don't know. I'd have to think about it. But I think the 9-volt motors, my experience has been that they're pretty reliable, but they get noisy over time. The gears will clang. I could show you after the call, after this, that they make noise. They sometimes have problems. The newer motors haven't been in service as much, right? Because they were manufactured early, newer. So it really just depends. I don't know. I have to think about that question a little bit more to give you something worth using. Yeah. We've ran the motors generally for multiple A&E style shows. So I find that most of the bugs that we run into are bugs with the design rather than issues with the motors. But if you do more than a couple years of A&E shows, you're going to see some issues with motors every once in a while. So, yeah, maybe hundreds of hours of running. Yeah.
With what you had example with the track or the gap, how important is it that the gap is precise with the tread, or if you wanted to say something that's a little curvy but underneath it's straight, can you do something that goes around that, or do you really need to gear the tread to follow your gap?
Yeah, so I think you can kind of see maybe in that GIF a little bit that I didn't do angled system bricks. I have it kind of jaggedy around, and it's all just kind of a balance between what you find aesthetically pleasing and how much you want to risk having those clearances be tight. But I try to make sure that nothing, I try to get at least one stud clearance between a moving element and something that's not moving. Maybe more depending on how comfortable I am with the mechanism. So if it's my first mechanism, I'm going to do something bigger. If it's something I've done a couple times, then maybe I'm more comfortable with it being a little
Well,
closer.
if your path curved, you
Yeah.
might need to keep the tread underneath it within a stud.
Yeah.
Curve.
Yeah. Yeah. You don't want that any part of that tread, whether it's curved or straight or anything. You don't want that touching any of the static stuff because that'll jam things up, and you'll either break the chain or stall the motor or something not good. So yeah, for sure. Yeah. Any questions from virtual folks? Nope. Okay. Cool. So moving on. Next thing I want to show is this ballet theater. And this one uses, we built a theater and we were like, we should have a ballet going on. And so unfortunately you can't hear the sound on it. But we have a programmable Lego Mindstorms brick behind that stage. And it is playing music. And then you see the people on stage are rotating and dancing. And so that's one of the advantages of these things is you can sequence the music and everything, and then we shut the curtains, and then the curtains shut, and then behind that we rotate the whole stage and bring up a new scene. So now there's that blue scene. Yeah, I know. That was the awesome thing. So we had 4 different scenes going of the Nutcracker, and then with different dancers dancing and music that the robot played. And so so that's the advantage of using a programmable Mindstorms type device. It's more complicated, and I'm not going to get into all the specifics on programming. There's actually a talk right after this in this room about programming those Mindstorms bricks. Oh, you can hear it. So yeah, we'll do we'll have the curtain go down, and then it spins, and then it comes back up, and then we'll hear the next song. Yeah. Anyway, so it was very cute, very fun, and so yeah. Let's see. Anything else on this? So anyway, if something like this interests you with a programmable brick, I highly recommend you stick around for the next talk that's on how to program these. So with that, I think I'm going to move on to how it works. I press the right button. Okay, so underneath the stage, we have all this gearing here. So there's one motor that turns all the dancers in all 4 of those scenes. And so there's a gear train underneath to rotate all of the dancers. You don't see the dancers in the other 3 stages that are the 3 scenes, but the one dancer runs. And then we have a yellow banana gear ring that rotates the entire stage around so that you see the different scenes. So that was the magic sauce behind how this worked. So let's see. And then the curtain. The curtain was the thing that had all these problems. So this was the original version of the curtain. We used this cool roller coaster track, this was right when the roller coaster track came out, so we were all figuring out how to use it. And it's like, I'm going to take the curtain, have it go side to side, and we'll use the roller coaster track as a bearing. And so the curtain was hung on this roller coaster that we then pulled across. And it worked great when I first built it, and then I took it to a show, and it had all these problems, right? Who would have thought? You should test it more and test moving it, and then so it had these would jam, it had problems. So after spending, I don't know, 6 months dealing with that, I finally gave up and was like, okay, we're going to do a winch system and lift up that curtain and down. And so, yeah, so that proved to be a lot more reliable because I wasn't having to take those curtains and go around a curve. So that was the idea with that. So the programming, I'm not going to go into a lot of details, but we used a Java text-based programming for that programmable brick, and it sequenced the dancers, the stage, and the curtains. There was some challenges making the music work because the programming language, you could output a certain frequency for a certain number of milliseconds, and so I had to do a lot of math and things to like figure and then hand compose the Nutcracker pieces to get into that. So it was a labor of love. It was very fun. So yeah, and then there were some other little nuances with it, like when you rotate the stage, the dancers will rotate a little bit too. So you have to recalibrate the dancers as they rotate, and so anyway, some nuances in the programming, but overall, that's the idea with that project. Questions on that? Yes. No. Any other questions?
I had a question.
Oh yeah, sure. Yeah.
Can you go back to the slide where you had the insides of the stage?
Oh yeah, sure. This
So-
one. Yes.
Do you use like an online program to plan this out, or do you just grab pieces and?
I just grab
Creative.
pieces and prototype. I don't use Studio for moving things. I've used Studio for little detailed things, but what I have found using Studio for moving things is that it's hard to know, like just because it looks like in Studio that the gears mesh and that everything's going to work, it may not. And by the time you spend all the time figuring out if that's going to work, it's like you might as well just put it together. And Studio's not going to tell you if your thing is rigid enough that if you pick it up from one place to another, is it going to work or not, right? So I have generally, for moving things, I don't use Studio. But I know there are lots of other smart people who do it that way. That's just not personally what I do. Yeah, anyway.
That's awesome.
Yeah,
Thank you.
so. But Studio is a fantastic tool. I presume there's other talks on using Studio or other types of CAD tools for it, and it's great, especially if you have a small inventory. You can, prototype things with the infinite inventory that's in that software. So that's great. I just personally don't use it for moving things. So yeah, let's see. Any other questions? Nothing from virtual attendees? Okay, cool. We're going to move on then. The next project that we did a big jungle. That our lug was like, we're going to do a jungle display, and we're like, oh, awesome. We're going to build a big volcano and do all these fun things. And so we had, there are 3 elements to this jungle. There was a waterfall, there was a boulder chase, and a bubbling lava river. And we're going to go through each of those first. So this first thing we did was this waterfall. And this, again, uses a chain. It uses a bigger chain than the original chain that we used. It uses this 3-wide Technic chain, and then you can affix bricks to it, as you can see on the right GIF. And so you can affix blue bricks to it, and then the water goes down, and then it goes behind the hill and comes back up, and then does it again. And there's actually, I believe, there's a mock down in Fantasy that has this awesome rainbow river that's is the same concept as this. This proved to be very reliable. I really like this 3-wide chain. I find that it's a lot more sturdy and less likely to break. So I haven't had issues as much with tensioning this, and I'm sure you would have issues with that if you built something big. But big chain and small, relatively small distance that it's going is going to end up with a more reliable product. This was also one of the first MOCs that I found that I really like transparent elements and moving. I find that those work really well, and it brings out the shine and gloss of the transparent when you integrate it into a moving element. So that's fun. And again, this was finally I had figured out, I don't have to worry as much about the gaps. And so there are gaps, but everybody's like, but the waterfall's cool, right? So that's my advice, is don't worry as much about the gaps when you're first starting out. So yeah, so that's the waterfall. Next item, I wanted to do Indiana Jones being chased by the boulder. And so I was like, how are we going to do that? So here's the GIF of him running around in a circle and then gearing to make this boulder roll behind him. And so I think I've got an example. So again, I use that roller coaster track to help kind of support it. And we've got one motor that rotates the whole thing around. And then there's another gear that as that's rotating, that moves an axle that then runs across it and then over to gearing that rotates the boulder. And so that took some finagling to get the gearing just right to make the boulder look realistic. But yeah, so that was super cool. There were reliability problems with this. So it would just jam up over time. And I rebuilt this multiple times because I would show it it would work fine for a couple hours and then it would jam up. And so rebuilt this multiple times and could not figure out what it was. I tried different bearings and different things. And it just would not work. And I was about ready to like give up on roller coaster track. I had figured, oh, it's the roller coaster track. It's just the roller coaster jams up on the track sometimes when it turns around. And I was wrong. It wasn't the roller coaster track. It was me. There was a geometry problem where I had the roller coaster track a half stud forward of the angle, which meant that these wheels would jam up on the curve. And it would work just fine if you just ran it for a few minutes and did a small test. Like it would work just fine and it looked just fine. But if you actually looked at the geometry, it wasn't quite centered on the thing. And so the geometry mistake was just enough that it would work for a little bit, but then not work reliably. And so that's the lesson learned is be really, if you're having problems and you can't figure it out, double check the geometry again, just to make sure that you're not doing something where when you build large things, it's not like if you're building something small and you're off by a half stud, it's like you'll notice. It won't come together. But if you've got something big and you're off by a half stud, you can put it together. It'll work just fine. It'll look just fine. So you got to be more careful when you're building large things that it geometrically works. And for a non-moving thing, it'd be perfectly fine. But when you've got something moving, that can result in reliability problems. So just being careful of that and then doing more testing. Look at that, more testing. Wouldn't that be great if I had just done some more long scale testing? And so now what I generally do now is I build the prototype. I don't invest in making it pretty or anything. I build the prototype and then I go run it for a day while I go build other things and see over that day, does it fall apart? Are there problems? Does it jam up? And check that. And so that tends to not take time because I'm building something else, but allows me to do the testing that's needed to make sure that before I fill it with jungle, that I don't have to then take it all apart to then fix it, right? So that's the lesson learned. The next thing that was cool on this, we did this bubbling lava river for this volcano. And that's the final product. It looked awesome. And so the way that we did this is we used this net element. And this technique is actually what's used for, there's a t-shirt down in the convention hall that uses this net, and then you affix one by one round elements to it. And then it's like flexible. It's flexible, but it stays together as one thing. So we did a sheet of that with transparent red dots to get the lava. And then underneath, we have these piston poker things that poke up on the lava at various spots to give this bubbling aesthetic. And it was super cool when it was made. And it worked great. The nice thing about this is if a particular element jammed up, it was all completely hidden under the lava. And you still had a bunch of other pokers that were still working, right? So that's another nice element to think about is if you have a way to make your moving thing that if a part of it doesn't work, nobody notices, that's great. that makes it more reliable because you can still show it. And with this, even if the whole motor didn't work, it still looked cool, right? You could still show it places and people wouldn't be like, oh, there's broken lava. So that's a nice feature of trying to make things that have function and aesthetics, is if you can hide the function well enough that if the function doesn't work, it's okay, then you're good, right? Then you don't have to stress so much about getting the function to work. So that's another good piece of advice. Questions on any of that? That was a lot of functions, so yeah. Yeah.
Dave asks, any tips on building scaffolding to support builds on top of hidden mechanisms?
Ooh, yes, that is a good question. Yes, that is very important. So yeah, so like you've got, let's see. So what I like to do, this isn't a good example of it. I don't have a great example of it, but what I like to do is I cross brace, where you can take Technic elements and you can stack up a bunch of bricks, and then you can take a Technic brick and a Technic brick, and then you can run a Technic beam that connects those two. And so now you have a post that is strong not only if you push down on it, but also if you pull up on it or you bend it or anything. And so building those posts that way helps create a column of the length you want that is one solid piece that's not going to come apart. And so the geometry for that I generally use is one Technic brick and then 4 bricks and then another Technic brick. And then you can take a Technic lift arm or beam or another Technic brick and you can connect the holes and it'll work out geometrically. So basically what you want to do is you want to add a studs not on top feature to the structural element that will then make it strong not only if you press down on it, but also if you pull up on it or bend it or whatever. So that will generally make your structures pretty strong. And then using, the other thing that's nice is you can use Technic bricks. You can kind of see an example. You see how that red Technic, I've got Technic bricks that go a long distance. You can use Technic pins to then connect those all together. And so you could make something that's longer than like a 1x16 brick. You can make something that's 2 by however long you want if you have a bunch of those Technic bricks. So I really like getting those Technic bricks and pins and then the Technic lift arms and pins. And that's how I generally make large structural things that are hollow. And then 16 by 16 plates are also your friend. You can put those on top and then build whatever landscape or whatever you want to do on top of that. So yeah. Any other questions? Okay, what do we do? Okay, we're doing good on time. Okay, cool. Oh, sorry. Yeah.
Yeah, so I was interested to see, I'm trying to build like a water ride type thing. If I wanted the water to bubble while also moving forward, do you have any tips on that?
Ooh, that's a good question. So I think the bubbling, my favorite way to do the bubbles with that net. And I think what you could do is you could have something like these piston pokers that poke up on it, and then you could probably connect that water to something that you'd probably have to pull it one way, and then you'd have to have another mechanism that pulls it back, because you probably can't push. You can't push something like that because it's going to just bunch up. But you could probably do that, and then what I have on here are these piston things that are with like a Technic axle that pokes up. But I've also done this with the Lego wheels that are offset a little bit, and that's a more smooth way to push it up. And so if you were going to move this left to right also, you'd probably want to do that. I could show you something a little bit in more detail after this talk, because I'm sure what I said didn't make a lot of sense, but I have ideas on how to do that. Yeah, any other questions? No? Okay, cool. So I'm going to move on then. Next thing, medieval castle. So this is the MOC that we've brought here, and this is very large. Thank you, Simone, for building such a large, helping build such a large thing with me to make this all happen. So there's 20 moving elements. Yay! So for those who are here in person, if you haven't come down, feel free to come down. I'll be down there right after this talk to help make sure everything still works. But happy to answer more questions. I've got some notable items here. So first, the juggler. So there's a juggler on the edge. I showed a GIF of this earlier in the slides. But here's how it works. It's really pretty simple. It's got it has rotation inside the building, and then the clear elements that connect to the balls are offset at an angle. Really, I should have gotten another animation of it going sideways. But that's the idea, is that they're done like that so that they can then hide, and then the center point of those angle rotations is right at the wall. So you can make kind of a small hole for those to come out of. So anyway, that's the juggler. Next thing, the saw. So there's a carpenter that's sawing something. And so this has a motor that then rotates a piston, which then rotates another gear, and then goes to that gear interfaces with a rack that then moves the saw back and forth. So that's that mechanism. And that's, again, hidden in one of the buildings. So the nice thing about doing buildings like this is you can use the inside of the building as a way to hide the mechanism. So not, if you like interior design, then there's a sacrifice made because it's hard to do interior design if you've got a big mechanism in there. But that's an option, right? A way to hide your mechanisms is to hide them inside buildings. So yeah, so that's that. The next thing, so the brown dragon on top of the castle, his mouth opens and he breathes fire. And so this has another kind of piston mechanism, kind of similar to the carpenter, but it has a mechanism to open the mouth and a mechanism to move out the fire, and it's slowed down compared to the carpenter. But that's kind of the idea. And originally, the very first iteration of this castle, we had it on, we used a servo motor, and we had it on a remote control. And so the audience members could press a button to open the mouth of the dragon. And that was awesome. That's what I wanted to do. And then I got there, and people had a hard time pointing the remote at the dragon and getting it to actually work. So that was my lesson learned, is there's a human factors challenge with these remote-controlled MOCs, especially if you've got stanchions and people are kind of far away. It's hard to get them to angle at the right thing and get it to work reliably. And so after showing it once that way, I reworked it to a motor that runs continuously, because I ended up found that was more, people got more out of the moving dragon by seeing it move rather than giving them a remote and trying to get them to make it move and not having it work. So that was revised, and then the other challenge with this was I hadn't done dragons before, so trying to make that dragon head, not only make it, but make it in the right proportion that it would fit with the mechanism, and then fit the mechanism in the tower of the castle. That was a challenge. So yeah, when you layer in a lot of things that you're not experienced with, expect for it to take a lot longer to come up with a solution. And this kind of a thing I wasn't comfortable with doing, except that I had been doing this for many years. And so I think when people see us come with something large, it's because we've spent years doing smaller things and building up to doing something big that makes it work. So anyway, let's see. What's the next mechanism? So next, this sea monster. This also had a revision. So the very first revision to the sea monster in the port was we used these splat gears, which we thought would be a really nice way to get that motion to work and have it be low profile. Because the splat gears can integrate with system elements well and kind of hide close to the floor, and they're blue, right? So we thought those would look really nice on the floor. And again, it worked for, maybe like 20 hours or so. But after about 20 hours, the gears would jam up, and the guy was just not reliable. And this, I asked some lug members who were GBC people. That's my other advice, is talk to other lug members who are smarter than you, know a lot more mechanisms, and say, hey, I got this thing that doesn't work. And they said, oh, yeah, you've got too many splat gears. The more gears you add, the more friction there is between those gears. And over time, they rub up on each other. They, little microplastic bits of those gears get in there and gum things up. And you've just got too many gears. So why don't you go with the design down below, where you've got these parallel bars that it's a little bit different motion, but you can also take those parallel bars. Those are just Lego plates that are then tiled blue, and the mechanism is all hidden under the port. So that worked really well. The bar moves left to right, and then there are bars that make the squid monsters tentacles move. And so that has no gear, a lot less gears. And so that has worked a lot better. a lot more reliability. So so again, back to the very first thing, try to make things as simple as possible. Try to reduce the number of gears you've got, and also try to talk to other people. Let's see. Final thing I wanted to show is this green dragon with the wings flapping. And so this was a challenge. Like, I wanted to get all the dragons to move, and this dragon, it was like, I didn't hide the motor in the structure because I wanted it to be on the dragon and flapping its wings. So the motor is inside the dragon, which means the dragon's really fat. Simone said the dragon looks like a big chicken, and I'm like, well, I don't know what to do about that. So the motor's inside there, and it does the flaps. And then I did a bunch of these universal joints up the neck to the top of the mouth. And I'm like, oh, I could get some fire coming out of the mouth, right? And rotate it so the fire spins. And again, since it's transparent, it looks awesome. And so that was the idea. I'll say the one other thing that I didn't mention on this is that having all of those universal joints up there and then doing that neck with all the mixable ball joints means it's really fragile. I'm so surprised that I haven't had had any problems with that this show, but I'm wary of doing all of those universal joints to get it, but it works. So don't breathe on it. It works for now. So but that's the idea with that. And then the jousting arena. So the jousting arena is, again, like the Nutcracker ballet. It's got a programmable brick in there that sequences the joust, the juggler, the trumpeters, and the sword fighters, and the flag up there to say who's the winner. And there's a link to that on how that goes. Or for those who are there in person, you can come down and watch it. And so this integrates that belt that, again, over years I figured out that large belt with a relatively small distance means it's going to work pretty reliably, and the lessons learned from that programmable brick. The new programmable brick that I used, you can import wave files rather than hand compose all the notes and have it sound like boops and beeps. It actually sounds like trumpeters and everything. So fit well with the medieval aesthetic. Any questions on that? Yeah.
I was just curious. I love the timing of the sword fight with the sounds.
Oh, yeah.
Did that just take a lot of tweaking, fine-tuning just to get it right?
There was some tweaking. The EV3, the programmable brick, controls those sounds. So you tell it, spin the motor that controls the sword fighters for a little bit, and then immediately play the sound, and then do it again. And there's a bunch of random generations, so there's different sword fights. There's a couple different sword fight sounds, so it'll randomly pick one of those, and then it randomly picks, I think, the speed and exactly how much gap between the swings to make it look kind of more organic. But yeah, so there was a lot of finagling with the programming to get it to be just right. The sword fighters wasn't as big of an issue. The biggest finagling were those knights, because you have to get those knights to go around the exact right amount, because it spins it for a certain number of rotations, and then it'll do that again and again and again, and you'll run it all day. And if you don't get it just right, then over a day, if they go a little bit less, then they'll end up in the wrong spot after each joust. And so that took a lot of finagling, because, again, it would work great for about 20 minutes. We wouldn't notice the problem, and then you take it to a show and run it all day, and then it's like, oh, it's off. I need to tweak it by just the littlest amount. And it's actually, I had to tweak it to the point where every fifth joust is just a little bit less than the other jousts, like to get it to run all day without getting off. So yeah, so cool. Any other questions? I think that's pretty much it. Let me double check, but I think that's it. And I am happy to answer more questions or talk to people down in the convention. So thank you, everybody. Yeah.